So here we go. Got a lot of problems to do today. We're going to do a lab. Oh, we're going to do a lab tomorrow. And for that lab, I think it's going to be tomorrow. We're going to make it tomorrow because I feel like I'm ready for a lab tomorrow. For that lab, you need to bring some sort of candy bar or some sort of granola bar or some sort of something that's in a wrapper that you can remove the wrapper from. Does that make sense? So put that in your homework for tomorrow as well. Okay? It can be small or large. I don't care. Okay? But you need to bring some sort of candy bar with you. If you do not, you're going to be sad. So please don't forget. And don't run in here saying, can I go to it? Like, no, just do it. Bring it. Make sure you have it. Okay? Yeah. Yes, you may. Yep. Any sort of wrapped thing that you can then unwrap. Does that make sense? I guess it doesn't have to be food, but that's just what always is in my head because I like candy, I guess. Yeah. All right. Shh. So today, as I said, we are going to jump in and talk about acceleration. So here we go. Here we go. We talked about the first half of this already, but I want to make sure that we're all on the same page. If an object is not accelerating, then we know all about it because we did that last chapter, right? Kind of, okay? Oh, wait, hold on. Yeah, okay. If an object is not accelerating, what do you know about its velocity? The velocity is constant. Awesome. What do you know about the net force acting on the object? It has to be 0. Okay. Let's do the other half of the story today. If an object is accelerating, what do you know about its velocity? Its velocity is changing. Yeah. And what can you tell me about its net force? By process of following, process here. Okay. Not accelerating, but a constant force and a zero net force. If it's accelerating, velocity is changing. Tell me about the net force. It can't equal 0, right? Yeah. Logic puzzle tells us that has to be not 0. Okay. Fnet and A are very much related. Often when people teach this stuff, often when students learn this stuff, they think about it as Fnet being the thing that we really care about. But that's not how I see it. And after having taught it for a long time, the way I want you to think about it is to think about the acceleration. What does the acceleration, oops, I'm getting ahead of myself here. Seriously, come on. Depend on. The acceleration is the result. The acceleration is the result. It's the thing that is being equal to this other stuff. What has to be happening to an object for it to be accelerating?
Constantly increasing the force.
So it's going to be either increasing, right, or decreasing. We don't know for sure, but it's definitely changing. It's constantly changing velocity. What did you say? It has to be a force action. Net force has to be not 0. We just said that, right? We're just going in circles. Yes, absolutely. So it definitely is depending on a net force. So A is dependent on a net force. So let's think about that. So we've talked about forces. We've talked about that as being a push or a pull. So I'm going to think about what would happen if I have a box and I apply a little force as opposed to a big force. In which case am I going to get a bigger acceleration, ladies and gentlemen? Big force. It's logical, right? You've been studying that since you were a baby also, right? You push with a little, and then it goes a little, but if you push really hard, woo, there that thing goes, right? Right off of your high chair tray and right onto the floor. You know this, right? Yeah. So as F net increases, we know that the acceleration goes up. Is there anything else that acceleration is dependent on? If I apply the same net force to two different objects, will they accelerate the same way always? No. What else do I need to talk about?
Mass.
The mass, right? So if I push on a big boulder with 12 newtons of force, I'm going to get it to move, right? But its motion is going to be very different than if I push on a little pebble with that same 12 newtons of force. You with me? Does that make sense? Okay. Which one is going to have a bigger acceleration? The big mass or the little mass? The little mass. So this is the funny thing. As the mass increases, what happens to the acceleration? It goes down. As the mass goes up, the acceleration goes down. Okay? The acceleration is a result of a net force acting on a mass. We can write this down as an equation. The acceleration is a result of the net force acting on a mass. Here, I'm actually going to write it as proportions first because I like proportions better. As acceleration goes, or excuse me, as F net goes up, acceleration goes up. So they are this little funny thing. It's kind of like an alpha, but not quite. This thing is called proportional to, or that's what it means. Okay? F net is proportional to A. As one goes up, the other goes up. Are you with me there? Does that make sense? Okay? You can also write this as A equals some constant times F net. That's what we're saying there. Is it true to write that M is proportional to A? Why not? How can I fix this to make it correct?
Turn it sideways.
Now it's okay? I mean, you're not totally wrong though. It's like a different kind of turn it sideways. What do you want to do? I thought you were there, but I don't know if you were being snarky or not. Was that a snarky comment?
Megatron.
M is proportional to 1 over A. They're inversely proportional, right? Because I like A and I want A to be my result, I'm going to do the 1 over with the M. Is that okay? I mean, it's the same deal, right? Yeah, but I like my A because that's the thing I'm trying to write an equation for. So A goes up if F net goes up. A goes up if M goes down, right? So we think back to where our learning fractions, the bigger that denominator is, the smaller the value is. You with me there, right? Yeah, I'd rather have half of a piece of pie or half of a pie than a quarter of a pie. Right? It's smaller, smaller, smaller. Okay. So we're going to put these two things together then. This one goes here. This one goes here. We're going to put them together. So A is proportional to each of those things. We can also say that A is equal to, because those are the only two things that matter, the net force divided by the mass. Okay. A is equal to F net over M. Can you guys see that green? Or is that really too hard to see? I like that green, but is it hard to see back there?
I can see it.
You got kind of so-so? Okay.
Hey, kill it.
Okay. All right. All right. I just wanted to know because some people have said that, but I like it, so I don't want to give it up if I have to. All right.
I can't see it.
I can see it.
Are you okay?
He's colorblind.
Okay, so that's fine. What's the deal? Awesome. Yeah. My husband's super colorblind too, so yeah, whatever. It's all good. All right. A equals F net over M. That's like a big deal. This is the equation that you need to put a big box around today. This is it. You may have seen this before. There's this one guy that got really, really famous for writing this equation down.
Einstein.
Was not Einstein.
Albert.
It was a few years before Einstein.
Ted Lasso.
I'm done. You're done guessing. Your guesses are over. I will tell you.
Isaac Asimov.
Also, no. Again, a few years before. Same correct first name, though. Same, yeah. Anyway. Yeah. So, in most science classes that involve physical science or involve physics, the teacher forces students to memorize words that mean nothing to them. Okay? It's the same as my little kindergarten daughter, who I don't know if they still do this in elementary school, but I remember when I was a little kid, at the beginning of the day, you'd have to stand up and put your hand over your heart and you had to recite the Pledge of Allegiance, right? I pledge allegiance, blah, 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 blah. I don't know what these words are saying, but I'm just repeating them over and over because I was told to, right? But if they mean nothing to you, then you're just like, bleh. And that's the same thing that science teachers do all the time, and it drives me bananas. Because then people are like, oh, I understand Newton's laws. I'm like, yeah, you really don't. So I'm going to tell you, this is all you need to know. That's it. That is it. Let me walk you through it. Because you guys are smart. If F net is 0, what happens to A? If F net is not 0, what happens to A? That's all you need to know. That is it. Okay? That is all you need to know. I can recite the other things for you, but they don't mean a lot. And they don't make a lot of sense because it's like, take all this stuff. This is Newton's first and second law right here. Put a label on it. Newton. Newton's first and second law. It's right there. Okay? One equation. It's easy. You got this. Now, let me ask, and I don't mean this as a knock to you guys, because y'all are smart. But does it take a genius to come up with this?
Yes.
It does not. I can walk this through, like I could walk this through with, like this is not hard. Okay? The fact that it's named after this guy's like, oh, I figured it out. He didn't really. He actually did this is like his, I only understood this because I was standing on the shoulders of giants. That's like a super famous Isaac Newton quote. It's like the only time that he gives credit to anybody else but himself. Super full of himself. Don't like the guy. But anyway, regardless, even though he was like, blah, 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 we still call it Newton's laws of motion. Like, did he come up with it? No! The cave people that were living wherever in the world at the beginning of human history knew this, right? But they knew it, and you don't even need to be a genius to write it down in a formula. And again, no disrespect to you all, but you can do this because you could teach anybody that you meet that this is what it is, right? If this is 0, this is 0. If this isn't 0, this isn't 0. It's done. That's it. Got it? Okay. Question?
No.
You sure? Okay. Awesome. All right. So that is that's it right there. Boom. We're done. Now, that doesn't mean we're going to make it a little bit more interesting by adding some pieces to it, right? But this is what you need to know. That's the big picture thing. All right. I've got a few ranking tasks for you to look at. And then we're going to do some problems as well. Here they come. Question 1. Have we done this one yet? We have not, right? Okay, I couldn't remember because I feel like we did something else kind of like this, but I can't remember for sure. All right. Water skiers are pulled at a constant speed by a tow rope attached to a speedboat. Because of the weight of the skiers and the type of skis they're using, they experience different resistive forces from the water, and these resistive forces are F sub skis on person, right? That's how I would write it. And the speed of the skiers are given. The question says to rank the magnitude of the net force on each water skier. Okay? I'm going to let you think by yourself for a second, and then we'll put it together. But go ahead and think about this. This is you and your brain, not your mouth, not your vocal cords. Think about it, think about it. All right. Go ahead and start having a conversation. Once you come up with an answer, go ahead and write it on your board. So you can share that answer with me.
No, we are.
The ones with the higher.
Yeah, but because so it does like count.
It does because it has to more weight going back.
Make sure that you have either greater than signs or equal signs and things so that I can tell when you hold it up. So you have just a string of letters. I don't know what that means.
Yeah. Is going
I'm going to give you another 30 seconds. Get an answer, write it down. Get an answer, write it down. Don't hold it up yet, though. You don't want to give away your answer, do you? No.
I'm still skeptical.
Doesn't even write.
Do you need a different marker? All right, I want to see boards in 5, 4, write something down. 3, 2, 1, show me your boards. All right, let's see. I'm just going to write down some answers here. So I see, come on, stinker. All 0 back there. I see D, greater than B, greater than A, greater than C, DBCA, DBCA, DBAC. Oh, wait.
It's all 0.
We find it? We get it? All right. So Harrison just had a epiphany there that I feel like I want to. Can you narrate your epiphany for us, please? What just happened?
Constant speed. So they're all 0.
You did something.
Oh, we're so stupid.
You're not stupid. You're not stupid, but it does take a little bit of attention to detail, right? Okay. So what's the right answer, friends? All 0. So if you had this question on a test or a quiz, then you would say all 0 and you'd be like, I'm so cool. But then there's also this explain your reasoning, right? So when I do these, it's like 1 point for this and like 2 or 3 points for this. So what's your reasoning going to be? What are you going to say?
Constant speed.
Constant speed. So if you just write constant speed, I'm going to be like, that's just 1 point. Tell me what does that mean? Constant speed means what?
F net
is equal to 0 because what is equal to 0? All right, let's do another one. All right, take a look here, ladies and gentlemen. Various similar boxes are being pushed for 10 meters across a floor by a net horizontal force as shown. So that's a net horizontal force, okay? The mass of the boxes and the net horizontal force for each case are given in the indicated figures. All the boxes have the same initial velocity of 10 meters per second to the right. It says rank the acceleration of the boxes. So I'm going to give you like a minute and a half to work to think by yourself, and then I will let you discuss together. Does that make sense? So this is you and your brain. Okay, please put the caps on your markers if you haven't done so already, just so that they don't dry out, okay? Thank you. All right, go ahead and think for a minute, and then I'll let you talk. Henry, pay attention. Work on the problem. All right, have a conversation with your table. Come up with an answer and write it down on your board. So it's not a trick question.
How's that going?
Yeah.
So you
put a box around each. So you probably don't split with the
He's greater than A, he's greater than D. Bad. You take the NP test. It's your first name. Is this your only class? Oh, because they didn't count. You're not gonna be a national IT student. Oh wait, yeah, Rudy could get it up. That's my good name. BS. No, you can't get it up. You're only it's not worth it. It's actually useless.
That was ADC.
You get a 4. It's not worth it. No, Rudy, it's definitely not worth it. Colleges don't care.
So what?
Oh, me and Rudy had this arbitrary goal to get a national AP scholar after a junior year. You have to get a 4 above.
It is possible.
No, but like for us at the moment, because we were going to take econ and that was 2 tests, so we could have gotten 8. But then they were done and offered it, but then actually didn't offer it, which made me kind of mad.
So can you take it or no? They didn't.
No, they just didn't. They told us they were going to offer it, but they didn't.
They probably don't have people, right? It was just
There was like 12 people.
Oh, that's fine.
So we're talking about like Rudy was thinking about self-studying for one of the tests.
I totally had people that did that at my old school. Like,
But it's a useless award.
I mean,
No, to get your junior
bragging
year,
rights. Like,
we'll both probably
you would be
get
the
next
first
year.
person at Liberty to get that by your junior year. Right?
It's really hard to get by your junior year, but
It is.
a lot of people get it as seniors.
Sure thing.
Through scholarships.
All right, let me see your boards. Boards up. ADCB, 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 ADCB. All right. Can somebody give me explain your reasoning? So you said ADCB, right? That's what we said. Well, that's yellow. ADCB. No, let's not do that. You say as you have like Cookie Monster on your shirt. I'm just saying, it's just interesting. All right, explain your reasoning. How's that going to go for this one? What's the why? How did you figure it out? Y'all did it. Yeah, you're going to say, so if you were doing this on a test, you'd say F net over mass or F net over M is equal to A. And then probably you'd want to like show me that process, right? So like write them out or explain to me that you could see that one was bigger than the other, etc. Yeah. We good? All right, let's keep going. What's this one about? Well, this one's interesting. All right. Two forces act on a block initially at rest on a frictionless surface. Rank the speed of the block after 3 seconds. So I'm going to let you think by yourself again. Two forces act on a block initially at rest on a frictionless surface. Rank the speed of the block after 3 seconds. All right, have a conversation. Don't fight over the whiteboards, gentlemen. Not worth it. All right, go ahead and talk to your paper mates. Go, 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 go.
D is the biggest one. Yeah, it has 10 newtons. No, that must mean no. I'm not taking the
Doesn't matter what way it goes.
Oh yeah. I'm gonna take AP stats because I'm gonna need stats in college. Yes. No, that's seriously. For you.
Are you ready or not quite yet? Yeah. Okay, I'll give you another minute.
Making yourself best. Your life's something. No, it was a different thing. This is literally a different thing.
It's just a washcloth.
It is.
For a baby. I don't know. It's just, or like a burp cloth. You could like put it over your shoulder and then burp the baby. It's not a bib. I mean, I'll judge you a little bit, but you have the ability. All right, I want to see your boards. Show me what you got. Let me see. B equals C greater than A greater than D. B equals C greater than A greater than D. Do you understand why or no? Okay, we're going to talk it through. B equals C greater than A greater than D. Now, again. Why? Oh, you can't see it. I can see it, but you can't. Boom. Thank you for reminding me. That was like amazing. It's poof. Magic. No, not really. But we'll pretend. All right. Now I want to know why. There's a lot to this problem. And this is one of those that if you don't explain it completely, then even if you get this right, you might not get the whole, like all the points here. So who would like to explain or get started on an explanation of why that's the right answer? Get us started. Yeah.
You want to find the net force first.
Okay, so I want to find the net force. How do you find the net force?
You find the difference between them, or you just subtract that 2 or the other way around.
Yep. So you're going to add so just a reminder, because we're going to start doing this with another problem with actual numbers in just a minute. In order to find the net force, you add all the forces that are acting, right? But in this case, we've got one force that's going positive, one that's going negative. You have to take those directions into account. Direction matters. So we'll take in part A, for example, we would do 8 newtons plus negative 6 newtons, right? Which gives you 2 newtons. So once I've found the net force, what do I do with that? I'm going to divide it by the mass. So I'm going to take the F net and I'm going to divide it by the mass, which will tell me the what? the acceleration. So for example, in A, then I've got 2 newtons divided by 4 kilograms, which gives me what? 1/2 what? Meter per second squared. Meter per second squared. Acceleration is going to be meter per second squared. Okay, am I done? What do I do now? What's that?
I multiply it by 3
Multiply it by 3. Why?
because it says rank them after 3 seconds.
They're all 30 seconds, so you don't need to do much.
So, okay, so we have to be a little bit careful here. If I wanted to find final velocity, so we haven't really written this out yet, but let's just talk it through real quick. Acceleration, maybe we did, I can't remember. Did we talk about acceleration as a change in velocity over time? Have we done this? I don't know. I get confused because I do something different order for you guys than for my other physics friends. But this is true. Is this okay? Acceleration is change in velocity? Now, here's my question. Do I need to actually find the velocity? Rudy says no. Why?
Because they all go for the same time, so you can just make the acceleration.
But I would need you to tell me this. I would need you to tell me that they all start off at the same speed. Happens to be at rest, I think. They all start at the same speed and they all have the same time. So if these two things are the same, then the final velocity just depends on acceleration. That piece is just as important as any other piece in that explanation. Does that make sense? You gotta have it. You doing okay? Life is good? Questions? Okay. All right. Mystery boxes are back. Woohoo! We're gonna do one of them today. I know you've been missing because you wanted to see. This is a picture of it. You've been wanting. Somebody was complaining about not having a picture of it before. Sure, whatever. It doesn't
Just
matter.
wrote out the.
Right. Yeah. All right. So here we go. We talked about this mystery box. This mystery box is not quite as pretty as the mystery box that I had in my head. I had one that had like really pretty paper on it and all kinds of things. I don't know. This one is just kind of like a crate. It's not very exciting. But here's the situation. Do you remember when we first were introduced to the mystery box? It was sitting there, and then our friend pushed down on it because we don't know why, and then pulled up on it a little bit because we don't know why. So now our friend is pulling up on it with a bigger force. Aww. A force that happens to be bigger than the normal force would have been. So what do you think is going to happen to the box?
It's going to go upwards.
It's going to go up. And there's a word instead of go that would be much more succinct and describe more clearly what's happening. Accelerate. Accelerate. It's going to accelerate, right? Because travel even, like that is true, but I want the most descriptive word I can come up with, and accelerate's a pretty darn good one. So we want to know, let's see, it says, what happens when a person pulls upward on the box, blah, 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 blah. So you've already kind of answered the question, right? It's going to accelerate. It's going to accelerate upward. That's not good enough for me. I want to know how much it's going to accelerate. I want to know what the acceleration is. Do you think right now you can just figure that out for me? Okay. You've already got your free body diagram. You're welcome. But from that free body diagram, then you can write an F-net equation. Every time you're solving a force problem, I want you to write down the F-net equation. Every single time. This one's pretty easy, but I still want you to because it's going to get harder. I promise. Give it a shot. I'm going to kind of get you started here. F-net. These are not labeled very well. I'm going to draw my own arrows. That's the force of the earth on the box. FG. That's the force of the person on the box. FA. So I've got an FG pulling down and I've got an FA pulling up. And now, in the first unit, we always said F net equal to 0 because we knew it wasn't accelerating. Now we need to set it equal to something else. Now here's the game, friends. You need to make sure you're paying attention. I've been showing you this, A equals F net over M. The reason I like it that way is because the acceleration is the result of the force being applied to the mass. I like this better, but we can also solve this for F net and say F net is, if you multiply by M on both sides, F net is equal to MA. Okay, that's the way that it's like been indoctrinated into your brains, probably if you've heard it before. This is the better way, but when we're doing these problems, we can write this as MA, the mass times the acceleration, then we can find the acceleration. Okay. This is what I want you to know, but this is how to apply it. Okay. How are we doing? You writing stuff down? Writing this down? Got a gravitational force of 98 newtons going downward. They didn't give us the 0.1. I'm just going to do it. So I've got 98 newtons going down. I've got 100 newtons going up. What's the mass of my box? Anybody? Yeah. Okay. So we've got 2 newtons equals 10 kilograms times A. See how cute it is? No, you're not going to get points for that, though. What's missing? Well, even beyond that, I'm not giving you points for the answer even. Yeah, I need some units on there. How do you get meters per second squared out of that business? Should we figure that out real quick? A Newton is defined, and I haven't told you this yet because we didn't know this yet, but I'm going to tell you now. A Newton is defined as a kilogram meter per second squared. Did I tell you that already? That secret? Oh, I did? Oh, okay. Secret's out. Okay. How are we doing? We okay? Issues, questions? Ready to move on? I'll start another one because that's fun. Or not yet? Yes? No? One more minute? Okay, fine. You guys are no fun. You're like, okay, let me tell you something real quick though. Given